Hey, it's Mr. Leatherwood, and today we are learning how to add fractions with unlike denominators. So, let's come up with a problem so we can practice a bit. How about, how about 3/4 plus, I don't know, 4/6. Okay, so Timmy ate 3/4 of his pizza, and his sister ate 4/6 of another pizza. What is the total amount of pizza they ate? Okay, so we're going to start with models. And so I'm going to draw a model of 3/4. My pizzas are rectangular because they're easier to draw. I'm going to make another model. And so 3/4, I'm going to cut them into fourths. You'll notice when I make my models, I go all the same way to start out. So for instance, 3/4 would look like this. And 4/6, I'm going to cut them into thirds first, then cut my thirds in half. But they all go up and down, and I'll show you why here in just a second. So I have 4/6, 1, 2, 3, 4. All right. And so the first key to adding fractions with unlike denominators is the denominator has to be the same. And the denominator, just in case you didn't know, is this bottom number. And the numerator is going to be the top number. Okay, so our denominators have to be the same, and right now they're not. They're 4 and 6, and I want them to be the same number. So one way to think of it is I'm trying to figure out what 4 and 6 can both be changed into by using multiplication. And so one number that I know 4 and 6 can both be changed into is 12. And the reason I know that is if I list multiples of 4, 4, 8, 12, and then I do 6, 12. They both can change into 12. And so what I'm going to do to my models is I'm going to try to figure out how to turn them into 12. And the way I do that is I think of it like an area model, or finding area of a rectangle. So down here I've got them divided into 4 equal parts, but I want them to be 12 equal parts, right? I want to change it to 12. And so what I'm going to do is I'm going to try to figure out 4 times what, or almost like length and width, 4 times what would equal 12? And I go, oh, well that's easy. 4 times 3 is 12. And so I know that I want to cut these into 3 equal parts. So I'm going to do that best that I can. So now I have 12 equal parts. And so I could change my 3/4 into something out of 12. And you'll notice my something, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal parts. And it looks like I have 9 of them colored in. So now my 3/4 changes to 9/12. So then let's look over to our other model. I had it cut into 6 equal parts to begin with, but I want to cut it into 12 again. And so I know that 6 times 2, or if I was doing length times width, 6 times 2 would equal 12. So I'm going to cut this one right in half. And when I do that, I can see that I have 12 equal parts, 6 on top, 6 on bottom, and I have 1, 2, 3, 4, 5, 6, 7, 8 of them colored in. So now my new number sentence, if I wanted to write it right underneath, would be 9/12 plus 8/12. So now I've got a common denominator. Both denominators are the same, and that's the key when you're adding fractions, or we'll find out when we're subtracting fractions. You have to have the denominator the same. So now I'm going to add across, but I'm going to keep my denominator the same. It doesn't change. I'm only going to add my top numbers. So 9 plus 8 equals 17. So my answer is going to be 17/12. Now you'll see that math people don't really like these improper fractions, so we'll end up turning this into a mixed number. And by now you should know that we're trying to figure out how many times 12 will go into 17. And it's going to go one time. Denominator stays the same. And then we're going to subtract 17, or we're going to figure out how many were left over. So 12 went into 17 one time with 5 left over. So our answer would eventually be 1 and 5/12. So that's how I use models to figure out the answer here. Let's do one more, a little bit different way. All right, let's try 2/5 plus 3/10. So I'm going to draw my little model first. And I'm going to cut my first one into fifths. Best I can. Doesn't have to be perfect. Then I'm going to draw another one. I'm going to cut it into fifths. And then I'm going to cut those fifths in half because I know that'll get me 10. Okay, not perfect, but it'll do. I'm going to color in 2/5 over here. I'm going to color in 3/10 over here. Not very well, but you get the point. Now, our first key is that the denominators have to be the same. And so right now, I have them cut into fifths and tenths, but I want them to be the same. Now you'll notice probably that 5 can be cut into 10, so I'm going to do that. It was 5 down here, 5 equal parts. And if I cut them in half, 5 times 2 equals 10. This one was cut into 10 equal parts already, so I'm just going to keep it the same. 10 times 1 is 10. And so I'm going to keep them the same, so that's going to turn this into something out of 10. And if you look down here, I have 1, 2, 3, 4 equal parts. And then my other one's just going to stay the same. So my new number sentence, I'm just going to bring it over here. My little arrow. It's going to be 4/10 plus 3/10. Okay. And then you'll notice if I wanted to, this is the little difference. If I wanted to, I could cut 1, 2, 3, 4. I'll go cut my tenths that way. If I wanted to, I could color in my 4/10. 1, 2, 3, 4. And then color in my 3/10. 1, 2, 3. And when I add those together, that's going to give me my answer of 7/10. So that's just a little another way to use your model to be able to do that. So we have 2/5 plus 3/10, which ends up being 4/10 plus 3/10 because we had our denominator be the same. We added straight across. 4 plus 3 is 7. Denominator never changes, stays the same. So then we get 7/10 as the answer. Try a couple on your own and see how you do. This is adding fractions with unlike denominators using models.